So point to be noted here is, everyone please pay attention. Wherever, I'm talking about now shortcut method. Wherever you want to find tension at whichever point, you cut the string from that point. You cut the string from that point, and the part which falls, that will be causing the tension. So just for example, if we cut here, okay, this 20 kg block will fall down. So that is tension in this string, which is caused only due to 20 kg blocks, and that becomes 20g. Okay. Now if I want to apply same logic on upper string, so if you are cutting it from here, what will happen? This part and this 10 kg block as well as 20 kg block, both will fall. Both will fall. So basically tension in upper will be caused due to 10 kg block as well as 20 kg block. So what you can write directly is T2 is equal to 10 plus 20 into G, and that is 300 Newton. Vedant is saying, sir, we can take any sign as positive. Try to understand Vedant. In this setup, none of the block is accelerating. And as they are not accelerating, it is immaterial. You can take any direction as positive. Opposite direction will automatically will become negative. So your answer will not be affected. Your answer will not get affected due to that. All right. All right. Next question. There is a rope. There is a rope, and mass of this rope is m, and length of this rope is L. So ML uniform rope, ML uniform rope. This is free end A and this is end O. Question: tension, find tension X at distance X from end A. You can also call it as free end. You can also call it as free end. Please find quickly. So Ram is saying, so the direction is taken as directions of gravity. You can take as any direction as positive. Okay. If the system is not accelerating, Ram, you can take any direction as positive. The opposite direction will automatically become negative. What does it mean? Let me tell you. I am taking you back to the previous question. See, when we solved, we took upward as positive. We took upward as positive. So upward is positive. So T minus mg is equal to 0. If I take downward as positive, then what will happen? Downward as positive. So what will happen now? Mg minus T is equal to 0. So what we are getting actually, T is equal to mg. So there is no effect on our answer due to selection of direction. Understood, Ram and Vedant? You can take any direction positive. Okay. Okay. So now let us talk about this question. So two persons have given the answer and they both are saying the same thing. Chrisley and Asmita. Everyone please give your answer. Jared is also saying the same thing. Okay, pay attention everyone. So as I told you that whichever is the point where you want to find the tension, what you need to do, you need to go to that point and cut the string or rope. So suppose I want to find tension at this point P, which is at a distance of x from end A as per the question. So I went there and I cut it from this like this. Okay. So which part will fall down? This part will fall down. So which part will cause tension at that point P? Only the part which is I have encircled, that would have caused the tension. So pay attention everyone. TP is acting upward. TP is acting upward. MG is acting downward. MG is acting downward. Now this is not capital MG. This will be small mg, and small m is mass of this part which is going to fall. So what we can write again, TP minus small mg is equal to TP minus small mg is equal to 0, and that will be basically TP is equal to small mg. TP will be small mg. Now the question arises is that how much is the value of small m. So again for that we are going to use unity method. So in L length mass is capital M. In L length how much is the mass? Capital M. So in unit length it will be m by L. So in x length mass will be small m is equal to mass per unit length into length. So small m comes out to be m by L into x. So let us put it here. So m by L into x into g. So this is the tension at point P. This is the tension at point P. And where is that point? It is at distance x from free end. Now just for sake of checking our answer, just for sake of checking our answer, everyone please pay attention. At x is equal to 0. Okay. Now at x is equal to 0, we are at which end? We are at end A itself. So if I put x is equal to 0 in that point, we get TP is equal to TA, and that will be equal to 0. Why? Because if you are cutting the rope from end A, nothing is falling. If you are cutting the rope at end A, nothing is falling, and as nothing is falling, there will be no tension. As nothing is falling, there will be no tension. All right. Okay. Now let us talk about this point O. So at and O, at and O, what does it mean? X is equal to L. X is equal to L. So T at O will be M by L into L into G. And what it gives us? Capital MG. Why? Because if you are cutting the rope at point O, entire rope will fall. Entire rope will fall. And as entire rope is falling, the tension will be due to the whole of the rope. Adric, it will be mg x upon L. You have taken distance from upper end. Adric, you have taken distance from upper end. That's why you are getting this answer. Okay. Noted, everyone? Understood? No, but question, read the question. Question is saying it should be from A. All right, next question, everyone. Next question. This is a block of mass M2. This is a block of mass M2. This is a rope. M1 the mass, L is less, and it is uniform. It is uniform. Basically, there are 3 points. This is A, this is B, and this is C, and this is exactly midpoint. Question says find tension at point, find tension at point A, B, and C. Find tension at point A, B, and C.
Hello. Hello. Hello, sir.
Please keep your mics muted. Ronald, thank you. Okay, everyone, please pay attention. So if you talk about point A, and if you cut the string from point A, M2 will fall. That means tension at point A is only due to M2, so that TA is equal to M2G. TA is equal to M2G. Now, if you go to point B, and if you are cutting it from point B, so what you can say, this part of row plus M2, this will be falling, and then you can see that TB plus half of m1. Half of m1 means m1 by 2 into g. This will be the tension at point B. If you go to point C and if you cut the string from there, whole of the m1 and whole of the m2 will fall. So Tc will be m1 plus m2 into g. So that's how we can get values. That's how we can get values. All right. So Tc is equal to m1 plus m2 into g. If you have any doubts, please feel free to ask. If you have any doubts, please feel free to ask. Okay. Good. Next question. Next question. So this is a block of mass 20 kg. This point is O. This angle is 53 degree. This angle is 37 degree. So obviously this will become 90. This is T1. This is T2 and this is T3. Question says find T1, T2 and T3. Find T1, T2 and T3. Please find. Pratyusha is saying that T1 is equal to 200, T2 is equal to 160 and T3 is equal to 120. All right. One more person to answer. T1 is equal to 200. Okay, everyone, please pay attention. So for T1, if I cut it from here, this 20 kg block will fall down. So T1 minus 20g is equal to 0 and T1 comes out to be 200 Newton. T1 comes out to be 200 Newton, right? Now let us focus at point O. Everyone, please pay attention. So when we are going at point O, T1 will be acting downward, all right? Because tension is a pull type force. If we talk about this, T2 will be acting like this. And if we talk about this, T3 will act like this. All right. Now pay attention. I am resolving these forces in this direction, this direction, this direction, and this direction. So if this is 53 degree, this will also be 53 degree. So this will be T2 cos 53 and here it will be T2 sin 53. Similarly for T3 what I can write, it will be T3, this will be 37, so cos 37, and this will be T3 sin 37. Okay, so along horizontal at point O, at point O, along horizontal, along horizontal. So what you can see is T3 cos 37 minus T2 cos 53, that should be equal to 0. So T3 cos 37 plus 4 by 5 is equal to T2 cos 53 is 3 by 5, and that gives us 4T3 is equal to 3T2. So this is one equation which we have got. This is one equation which we have got. Now let us talk about along vertical. So along vertical. So what you can see is T3 sin 37 is upward. T2 sin 53 is also upward. So what we can write is T2 sin 53 plus T3 sin 37 and minus T1 is equal to 0. Why? Because T1 is acting downward at point O. At point O. So T2 is T2. Sin 53 is 4 plus T3 is T3. Sin 37 is 3 by 5 is equal to T1 we have already calculated, it is 200. So basically this equations comes out to be 4T2 plus 3T3 is equal to 1000. 200 into 5 becomes 1000. So let me call this as equation 2. Let me call this as equation 3. And when you are going to solve these equations 2 and you will get by solve. I am leaving this solving for equation 2 and 3. So what do we get? T2 comes out to be 160 and T3 comes out to be 120 Newton. So this will be the answer. This will be the answer. All right. All right. Asmita, please check your answers. Asmita, please check your answers. Understood, everyone? Understood? Okay. Okay. Next question. I hope you all have noted. Question. So there is a block of mass 500 and there are massless pulleys, and this is string. Question is find tension in string. Find tension in string. Okay, all strings are ideal. String is ideal. Yes, Vedant, ask. Okay, pay attention. At point O, what is happening? This force is acting upward, T3 sine 37. T2 sine 53 is acting upward, but this T1 is acting downward at point O. So the upward forces are added. Downward forces, I need to subtract, no? Downward force, I need to subtract. Yes or no, Vedant? That's why I need to subtract minus T1. Okay, understood, Vedant? Okay, now answer this. Give me the answer, everyone. It's an easy question. Jared is saying 833.33 newtons. Suhas is saying 500 by 9. Asmita is saying 2500. Sia is saying 833.33. Komal is saying, sir, will it be same at all points? Because the string is same. It is a single string. That's why it will be same at all the points. Komal. Chrisley is saying 2500. Kimaya is saying 500 by 6, 5000 by 6. Okay. Everyone, please pay attention. This was, as I told you, an easy question. 500G will be acting downward and tension here it will be T, here it will be T, 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 T. So these all tensions are acting upward and 500G is acting downward. So how many T are upward? So 1, 2, 3, 4, 5, 6. So 60 minus 500G is equal to 0. That gives you T is equal to 5000 by 6 is equal to 2500 by 3 is equal to 833.3 Newton. Answer. So this is the answer. This is the answer. Understood, everyone? Understood? Any doubt, any question? Any doubt, any question? No, Shane? Any doubt? Okay. Next question. It is 500 kg. So force will be 500 G. 500 G means 500 into 10. That's how it became 5000. Pratyusha. Understood, Pratyusha? आजकल पढ़ाई में जी नहीं लग रहा तुम्हारा. नेक्स्ट क्वेश्चन. Please and rope. Let me show you pulley by orange color. All pulleys are shown by orange color and a rope of white color is passing all of them. Okay. This is of 200 kg. Find tension in string. Find tension in find tension in string. Can you see the screen now? Okay. Thank you. Please give me the answer. Okay, everyone, please pay attention. When 200G is acting downward and tension is acting upward, so T, 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 T. Okay, so what we can see is 70 minus 2G is equal to 0. So T comes out to be 2000 by 7, and that's the answer. That's the answer. Samarth has calculated and Gargi also. It has 285.7. That's fine. Understood? Okay. Next question. Next question. This is a wall and this is ground. And this is some block. This is some block. Capital M is mass, L is length, and F is force acting on it. All right. And this is stuck on the wall. Ground is smooth. So the question is, this is A, this is B. Find tension in, let me call it rope. Find tension in rope at at distance x from end A. Find tension in rope at distance x from end A. Please find. Get the answer, Suhas. Yes, rope is stuck to wall. Rope is stuck to wall. Yes, there should be some normal force. Okay, everyone, please pay attention. As Komal is saying, mg will be acting downward and will be acting upward, but these are not going to affect force along horizontal. So what we are doing, we are going at a distance x from here and considering this portion. All right. So if P tension here, TP. So what you can see is F minus TP is equal to 0 because the rope is not accelerating at all. The rope is not accelerating at all, right? Now the question is, how much is the value of TP? How much is the value of TP? So even if mg is acting downward, even if mg is acting downward, right? The horizontal force is F minus TP is equal to 0. So F will be equal to TP at all the, as mass is not coming into picture, it is not going to affect at all. If you want to write it as, you can write m into 0, which is equal to 0. So F is equal to TP. So tension at point P, tension at point P will be 0. Tension at point P will be 0. What formula you have created? Into x into a by l. What is this? There is no acceleration. There is no acceleration. Okay. And your formula is dimensionally incorrect. Or if you are saying x and l have same dimensions, then it is dimensionally correct. The formula is wrong. So the point to be noted is that tension in the rope at any point will be F is equal to TP. Are you getting? Jared? Jared, are you getting? Yeah, there is no acceleration. There is no acceleration. Okay, next. So now we are going to talk about questions related to acceleration. Question. And let us first take questions related to rope. Or let's say block. This is F and this is M. This is smooth. Find acceleration of block. Find acceleration of block. Please find, everyone. Please find. Okay, everyone, please pay attention. You are absolutely correct. Mg will be acting downward, N will be acting upward along vertical, N minus Mg is equal to 0, and that gives us N is equal to Mg. is basically a useless thing, but still we're doing it. So this is along vertical, along horizontal, along horizontal. So there is only one force. So F resultant is equal to F, and that should be equal to M into A. We are assuming that acceleration is A. So A will be F by M. A will be F by M. Any doubt, any question? Any doubt, any question, anyone? No, good. Next question. This is block A, this is block B. Ground is smooth, and this is string. So find, question says, find ये ये B and tension in string. Find AA, AB and tension in string. Find AB and tension in string. Please find. Everyone, please pay attention. Enough time given to all of you. Please pay attention. See, M2G will be acting downward. Nobody can change it. NB will be acting upward. Nobody can change it. M1G will be acting downward. Nobody can change it. NA will be acting upward. Nobody can change it. The whole thing system will be moving with same acceleration because they both are by the same string and both will move same distance towards the right in same time. So acceleration of A and acceleration of B will be equal. Also, tension on B will be towards left, tension A will be towards right. Okay, pay attention everyone. Pay attention. So for M1, I am talking about for M1. First along vertical, along vertical. So what we can see is NA minus M1G is equal to 0 because A has no acceleration in vertical direction because A has no acceleration in vertical direction. Okay, so that gives us Na is equal to M1G, which is an useless value. So this value is useless. Na minus M1G is equal to 0, and that gives us Na is equal to M1G. All right. Now along horizontal for M1, along horizontal, along horizontal. So what you can see is T is equal to M1 into A. Let me call it as equation 1. Let me call it as equation 1. So T is equal to M1A will be along horizontal. Okay. Now we'll be talking about for M2. For M2 along vertical, same along vertical, same story. And what will be that? NB NB minus M2G is equal to 0, and that gives us NB is equal to M2G. NB is equal to M2G. All right. Now along horizontal, along horizontal. Can anyone else can see the screen? Anyone else? So you can write F because it is towards right minus T because it is towards left is equal to M2 A, and that is equation 2. Very nice, Kimaya. Very nice, Deepika. So now we need to add 1 and 2. Adding 1 and 2. So when you are adding 1 and 2, what will happen? F minus T plus T will be cancelled is equal to M1 plus M2 into A, and that will be A is equal to F upon M1 plus M2. A is equal to F upon M1 plus M2. So that is the acceleration. Now you can put value of A in equation 1 you put value of A in equation 1. So you will get T is equal to M1 into A. And A is what? F upon M1 plus M2. So that becomes T is equal to M1 F upon M1 plus M2. So T is equal to M1 F upon M1 plus M2. That will be the answer. That will be the answer. Okay. Those who can see, please keep on taking screen and posting on Teams for the benefit of everyone. All right. So we got the value of A also, we got the value of T also. Okay. Now in the same question, listen carefully everyone. In the same question, we could have taken M1 and M2 both as system because both are moving with same acceleration in same direction. So what we could have done directly, F is equal to M1 plus M2 into A, and this could have been A directly is equal to F upon M1 plus M2. So it could have saved our time. Would have saved our time. All right. And after that, you can put value of. Asmita is saying, sir, but we want tension for the whole system. See, first thing is we want to know acceleration also. So we got acceleration. Now after getting acceleration, you can find value of t also. You can find value of t also. All right. And tension is not for the whole system. It is tension in the string. It is tension in the string. And string is between M1 and M2. String is between M1 and M2. String is between M1 and M2. All right, Asmita? Okay, good. Good. Can we move further? All right. Next question. So there are 5 identical blocks of mass m each. Okay. And they are connected by strings. They all are connected by strings. And the rightmost block is being pulled by a force F horizontally, and ground is smooth. Question says find, what question says is find number 1 acceleration of each block, and उसके बाद you need to find tension in each string. You need to find tension in each string. Find tension in each string. So there are 4 strings which are connecting those blocks, and you need to find tension in each string. Please find. Question is easy, you can quickly find answer. Okay, everyone, please pay attention. Time given. In this question, as all the blocks will be moving towards right with same acceleration a. So what we can do, we can consider all of them as a system together. So A will be F upon M total. F is F and M total is M1 plus 2 plus 3 plus 4 plus 5 on 5M. So our acceleration will be F upon 5M. Correct? Correct. And all the lazy people here are giving me wrong answers for the tension. All the lazy people are giving wrong answer for the tension. Pay attention. As I told you earlier also, in whichever string you want to know the tension, cut the string from there, which is removed or released. That was causing the tension. So T4, if you cut T4, then the last block will not move. So T4 is equal to M into A because that tension in T4 was causing its motion. So T4 will be M into A. A is F upon 5M. So comes out to be how much? F by 5. All right. Now let's talk about T3. So if you are cutting from here, so T3 is causing motion of last two log. If that string is not there, if that string is not there, which is causing T3, then so T3 will be 2M into A. T3 will be 2M into A. So T3 will be 2M into A is F by 5 and that is 2F by 5. That is 2F by 5. All right. Now similarly we can talk about T2. If you are cutting it from here, last three blocks will not move. So T2 is equal to 3M into A. is equal to 3m into f upon 5m. So T2 comes out to be 3f by 5. T2 comes out to be 3f by 5. Are you getting it, everyone? Now let us talk about T1, which is connecting first two blocks. So if you cut it here, these blocks will not move. So what you can write is T1 is equal to 4m into A, and that is 4m into A is f by 5m. Mm got cancelled. T1 comes out to be 4f by 5. This will be the answer. T1 comes out to be 4f by 5, and that will be the answer. Okay. Okay. Any doubt, any question, anyone? Any doubt, any question? Okay. Okay. Next question. This is a pulley. This is block of mass m which is hanging m1 basically. This is m1 and this is m2. Okay. Ideal pulley and string. What do you mean by ideal pulley? It is massless, frictionless. What is ideal string? Massless, frictionless. Okay. So you need to acceleration of A and B. Find acceleration of A and B. Please find out one. Okay, everyone, please pay attention. So M1G will be acting downward. Tension, let us call it T, it is acting upward. For M2, M2G will tension T will be acting upward. Now we are assuming that M1 is heavier. So M1 will go down with some acceleration A, and by same acceleration M2 will go up. M2 will go up by same acceleration. Okay. So what we can write is for M1 and that will be M1G minus T is equal to M1A. Try to understand why and how we have written this equation like this. See, the motion of M is downward, or I should say acceleration of M1 is downward. So if acceleration of M1 is downward, that means downward force should be effective, or you can say more powerful. That's why I have written it first and I have considered downward direction as positive. Why? Because it is accelerated along downward direction. So M1G, which is downward, minus T because T was upward, is equal to M1 into A. This is for M1. Now for M2. So for now what we can see is that M2 is accelerating upward. So which force should be effective on M2? It is T. So T minus M2G, this is our F resultant, and that should be equal to MA. And how much is mass of M2? It is M2 into acceleration is A. So this is equation number 2. This is equation number 2. So in this question, we have two equations and two unknowns. So we can solve them easily. So let us adding 1 and 2. So what do we get is M1G minus M2G is equal to M1 plus M2 into A, and that gives us A is equal to M1 minus M2 into G upon M1 plus M2. Okay, so that will be the answer. That will be the all right. Now, if you put value of A in any of the two equations, either first or second, you will get answer of T. So by putting value of A in equation 1, we get, and I am writing the answer directly, T is equal to 2 M1 M2G upon M1 plus M2. Someone please do the calculation and verify whether I have written correctly or not. Okay, please check yourself whether the answer of do the calculation quickly. Please do the calculation and find the value of t. How much is the value of t? Are you getting the same answer? Adric is getting the same answer. Vaibhavi is also getting the same answer. Next question. Gargi is also getting the same answer. This is M1. This is pulley. Okay. This is smooth. This is A and this is B. Find acceleration of A and B. Find AA, AB and tension in string. Find AA, AB and tension in string. So in this question, 1G will be downward, tension will be acting upward, tension will be acting here, M2G will be acting downward, and N will be acting. We are assuming that A is sliding downward, so this will slide by A acceleration towards right. So for A, we can write M1G minus T is equal to M1A. Okay, now for B, there can be two cases. One is along vertical. So along vertical, what you can see, N minus M2G is equal to 0, which is a useless equation. Along horizontal, what you can see, T is equal to M2 into A. So this is equation 1, this is equation 2. So if you add 1 and 2, so adding 1 and 2, so what do we get? M1G M1 plus M2 into A. A comes out to be m1g upon m1 plus m2. A comes out to be m1g upon m1 plus m2. And if you put value of A in equation 2, so T will be m1 m2g upon m1 plus m2. That is the answer of T. That is the answer of T. Okay. If you have any doubts, please feel free to ask. If you have any doubts, please feel free to ask. All right. Understood, everyone? Understood, everyone? So we'll be solving more questions further. Yes, you can post your doubts on chat section. Okay. Okay, everyone. Thank you so much. Why is T1 is equal to M2 into A? T. Vedant, please pay attention. See, if you see, the only horizontal force acting on M2 is T. And what is causing motion of M2 along horizontal? It is only that force. So that's why F resultant, which is T, is equal to mass of M2, which is M2, into its acceleration, which is A. Okay. So that's how we get T is equal to M2 into A. All right. All right. Okay, everyone.